Hi everybody. This video discusses the RMS voltage of an AC source and what we mean by RMS voltage. So RMS voltage, and the RMS voltage of an AC source. So imagine we have an AC source here and it's driving some resistive load. Okay, the RMS voltage of this AC source is the amount of DC voltage it would take for us to get the same dissipated power in the same resistive load. So can I write that down here? Well, let's see. So this is going to be RMS voltage is the value of DC voltage that would give the same dissipated average power. So average power in a resistive load. As the AC source. So instead of referring to AC sources as their peak value or their peak-to-peak value, when we say, that this AC source is, say, 120 volts, we mean 120 volts RMS, okay, for example. So let's see how we figure out what that voltage is in relationship to V peak or V peak to peak. So the first thing we want to consider is that there's a current here, right? There's current in the circuit going through the resistor. The power then dissipated through that resistor is going to be VI. Now it's the full source voltage across the resistor. So for the case of the AC source, so the AC power circuit, it's still VI, and we could rewrite that as V squared R, right? Knowing that I is equal to V over R. So power is V squared over R, and in the case for the AC circuit, that waveform is V peak sine omega t. So we've got, it's a sine wave at some frequency, okay? So that's going to be squared divided by R. And if I bring the square through, V peak gets squared and the sine gets squared, and you write it like that, okay, over R. Now, if you remember any of your trig identities from high school, if you took that in high school, or if you're going to take it in a future math class or a current math class, you may recall that sine squared of something is equal to 1 minus cos 2 of that something over 2. So this identity effectively converts a sine squared into a cos. So the square is now gone. So if I sub that in, I'm going to get that my AC power is V peak squared times 1 minus cos 2 omega t over 2. Okay? Oh wait, I forgot my R. Okay? So if I bring, I'm going to bring the 2 out and I'm going to multiply this through. So I'm going to end up with, let's change pen colors, I'm going to end up with VP squared over 2R minus VP squared over 2R times cos 2 omega t. So you can see that there's two parts to this AC power. This part is a constant, and this part is a cosine wave, right? So this part is the cosine wave. It's doing something like this, right? And up at the top here, we said that it was average dissipated power that would be the same. So when we go down and look at this AC power through that resistor, we've got a constant term and then we've got a cosine term. The average of a cosine wave is 0 because these positive points are going to cancel out these negative points, and because the area of them is equal, you're not going to have this term when you average it. The average of this is going to be 0. So that term disappears entirely when we're talking about average AC power. So our average AC power is just going to be VP squared over 2R. And let's go back up again and look at the DC circuit. So we said that the RMS voltage was the value of this supply that would give the same dissipated power. So this is VRMS, okay? And the power then through that resistor in the DC circuit, the power is going to be still V squared over R, where V is VRMS. And it's the same resistor. So we said that that these two are the same, right? The definition is that this VRMS is the DC voltage that would give the same power. So we're going to set these two power equations equal to each other. And R's cancel out. I'm solving for VRMS, so I need to square root both sides. If I square root this side, that gets rid of the square. If I square root this side, I have to square root top and bottom. I'm going to get VRMS is equal to V peak over the square root of 2. Okay, and that's where that definition comes from, that VRMS is V peak over the square root of 2, which is approximately 0.707 V peak, right? So if we have an AC waveform with a certain V peak, we can figure out the RMS value of that AC voltage.